hello, everybody. Thanks for coming, and welcome to the talk about the art of the porcupine. So I'm developing this game here called Days of the Porcupine, and I'm going to talk about its art and shading style for a bit. OK, introductions. My name is Theresa Latzko. I'm an indie developer who makes things for fun mostly. My background and education is actually more in film and feature animation. I got my degree in character animation from CalArts, and afterwards I worked for Disney Animation as a character technical director for a bit, and worked on the Zootopia movie that was just released. I've been using Unity for about 4 years now, and I picked up scripting and recently shader writing on the way. So far, I'm making this game by myself, which influences a lot of the decisions that I make. And it's being made for PC. And I noticed that apparently this is also a talk about how much I love gradients. So there's going to be a lot of gradients. Let's get started. So for deciding on a style, at first, I got to think about what kind of game am I making. So I should explain that to you. So the game that I'm making is a single-player RPG in which you play a magician and you don't fight, but instead you use magic and magic rituals to get ahead in the story. And the world itself is supposed to be fairly friendly and mystical and kind of a fun place for the player to explore and to get lost in. So here's a wish list with the kinds of things that I wanted. And the whole thing kind of boils down to, I want something that looks good, that is fast and easy to make, but also has good performance. So it's kind of a greedy wish list. OK, so here's a little cross-section of art that I looked at and thought I really want to be able to make a game that looks like that. It's actually a coincidence that all of them show forests, but it's not so surprising because I really like forests. OK, so after having the initial gut reaction of I like these paintings, it's helpful to break down what I actually like about them and if that's something that I can implement in the game. So generally, you have very stylized and flat shapes here that are very close to primitives. So by that, I mean things are generally represented in their most basic versions, like the trees being pretty much just spheres. You have mushrooms, semi-spheres here. So everything's very simple, but there's just enough detail to get the point across. You've generally got vibrant and larger-than-life colors around an organic shape language where things are organized in a very nice rhythm and flow very well. They've got a stylized way of handling lighting and sort of use 2D gradients to suggest lighting. They use cast shadows on the ground as interesting visual design elements. And there's floaty particle blitz and lots of dot eyes. So these are all things that I want. OK, next up, I did some drawings of my own and tried to pick up on some of these things that I liked from the art, and tried to get a feel for what kind of world this is and who would be living in it. And doing paintings like these actually helps a big deal, even if you're just making the game by yourself. I'm by no means a professional concept artist, but just scribbling stuff out really helps you think. And it's much faster to figure things out this way than it is if you try to do it in modeling. So doing like a little painting like this would take me maybe a couple of hours, but I would actually get sort of weeks of mileage out of it in terms of being able to model parts of it, model variations of that, and so on. So they're sort of good jumping off points. And reference is usually helpful. OK, now onwards to the technical implementation. OK, so the first and most obvious approach is put some textures and materials on things and put some lights on top. And that might seem like a weird thing to even bring up, because in 90% of cases, that's how computer graphics work. But I'm still mentioning it because with what I ended up doing, I actually sort of skipped 2 out of those 3 steps. So this is the first time that I was trying out basic Maya to Unity pipeline, and it's just a sort of bare minimum. And obviously, usually stuff looks much better once it's fully textured, etc. But there's still a couple of fundamental things. For example, with this workflow, texture painting, UV mapping, and figuring out normals all takes time. And I want to save time so I can make lots of assets. There's a lot of steps from designing something to being able to see it in the game in the end. OK, but then CG lighting looks like CG lighting. What do I mean by that? I'm going to try to explain that a little better. So now we've reached the part of the presentation where I complain about Nintendo games with really great art. And obviously, the Nintendo folks are amazing at design. These pictures are just good examples for what I'm talking about. And they make sort of gamey-looking games, and it's very much a stylistic choice for them. But to me, there's something about the traditional method of doing basic non-global illumination CG lighting in stylized games that ends up making things look distinctly CG. And I think it's kind of imbalanced in levels of realism, where you have a stylized lighting setup, aka you have just one light and a little bit of ambient light, like fake ambient light, which you never have in reality. Then you have stylized textures, you have a stylized model, like this is pretty much just a sphere. But then the way that lighting treats the surface is completely realistic and mathematically correct. And this imbalance in realism is usually what makes something dip into the uncanny valley, meaning it comes across as wrong, although we can't really logically explain why. So to deal with this, we can either come up with a different stylized lighting model, or we can cut out lighting entirely. So I ended up doing 2 things that are sort of related and solved some of the problems that I talked about. First, working with flat and unlit shaders. Easy enough, and I just made a very long case for why I like to do it. It's also a lie, because we're still going to light things, but in a different way, but more on that later. And second, vertex coloring the models instead of texturing them. So we're going to be in Maya world for a bit now, because that's what I use to make assets, but the basics of this work pretty much anywhere. So Maya lets you assign vertex colors, and it's sort of, usually you have textures that are assigned by UV coordinates, but in this case, we just assign the colors to the mesh directly. Yeah, again, Maya lets you do this. My favorite plugin to use for it is Vertex Chameleon, which is like a little 3D Photoshop inside of Maya, but there's Unity extensions for it too. OK, so I'm going to take you through a quick step-by-step of using this workflow. So here's a really vague doodle. Next up, we have the basic model that I did. And then to start coloring, first I turn off the light. So when previewing the model without lighting, it's just going to display any vertex colors assigned, which in this case is none at all, so it's black. Now I assign some base color. As you can see, it's still 100% flat. And you can also see here what the plugin looks like. There's a lot of fancy stuff there going on. But to be honest, in most cases, I just end up adjusting hue, saturation, and value of different components. So that's why this works pretty much anywhere. I add some broad details, generally just the bare minimum of what will make it read. And then I deal with these a lot. These are vertex faces. This is just a display mode, but the cool thing about this technique is actually that you get to assign a color not just to each vertex, but basically to each face adjacent to a vertex. So we technically get 4 colors per vertex. And that's how we can get soft and sharp transitions, because otherwise this would just blend into each other. And controlling this is a fairly big part of coloring like this. And it's sort of similar to designing and painting something in 2D that way. OK, so here's our finished guy. I added a couple of more transitions and details. And one of the cool things about this is if I want to make any changes, I can just model them in at any point without having to worry about adjusting UV maps, etc. So I'm going to show you a quick turntable of this guy. So basically, we just see there's pretty much no surprises. Things are exactly the colors that we assigned to it. All right. OK, so this is a very different workflow from texturing. So it has a couple of advantages and disadvantages. One of the advantages being we don't have to deal with UV mapping anymore ever again. Then we get to color and model simultaneously, which feels sort of similar to designing in 2D. And what's really great is that we have an accurate preview of what this model will look like in the game in front of us the entire time that we're working. And if we have props that belong in the same environment, we can also adjust them to go together. OK, now it's time to take a look at everything in Unity, and we can bring our example blob king over with us. And when we bring in the models, stuff looks exactly the way that we designed it and exactly the way that we expected. And there's a little bit of shader wrangling to get it to display first, but just displaying basic vertex colors without any lighting on top is actually really simple as far as shader writing goes. And if you ever want to try out this process, there's info on vertex color shaders on the Unity forums and on the wiki. Another cool thing about this is that we don't have to deal with texture exporting, because when we do an FBX export, the colors are just stored in the mesh. So that also means that we just need one material to display all of this. OK. Now onwards to the part where I lied and said we weren't going to light anything. Now we're going to light things. So we work towards a flat style that relies more on silhouette and colors than on the shape of the surface. But there's still a couple of things in lighting that we want to do. We want to be able to create variants and create focal points. Like by focal points, I just mean where you end up looking. This background layout from Bambi is a really great example. If you squint your eyes at it a little bit, you can tell exactly where you're supposed to look. Also, right now, with the way a shader works, there's no way to make anything dark besides designing it that way. So we want to be able to do all these things, but we still want to keep that flat designs and style that we came up with, even in potential lighting situations. So again, that's a little bit of a greedy wish list. Really quick normals, because it's sort of important for the next part, are just vectors that are perpendicular to their polygon. And for us, they're important because they tell us what direction a face is pointing in. So here's the little painting of what I actually want lighting to do, because I want lighting to do sort of weird things that it's normally not supposed to do. Here's the super basic flat version, no cast shadow, nothing. This is a sort of shittily painted version of the realistic lighting model, where light's coming from here, there's a cast shadow, bright part here, dark part here, there's sort of a soft transition between. And you can tell very clearly what the quality of the surface is usually. This is how traditional tune shading works. You just split these things out into distinct planes. So with that technique, we still end up knowing very much about exactly what the surface of the object looks like. So that's not really what we're going for either. What I'm kind of going for is I want to apply like 2D gradients, sort of like this, and sort of do real fake lighting. So when I thought about what I actually wanted lighting to do then, I realized what I wanted to do is I wanted to treat all sides of the object the same way. I don't want it to care if a vertex is on the backside of an object and should be darker. I just wanted to have a nice, soft, uniform fall-off. And at first, I thought that was going to be really hard. But when I poked around in Unity's lighting calculation a little bit, I realized that it would actually be pretty easy, because lighting works this way anyway. Like the way it usually works is first it does a distance calculation where you assign brightness to the vertices based on how far away they are from the light source. And once you have that, you take that calculation and you combine it with the result of a normal calculation. So the normal calculation usually says, hey, shader, tell me if this face is pointing towards the light source and at what angle, and then make it darker or brighter depending on that. And if a face is pointing away from the light source completely, don't illuminate it altogether. So that's how you get this transition that I was showing in the painting. And I realized that's just exactly the part that I didn't want it to do. So to do lighting the way I wanted, I don't even need to add anything. I just need to take out this calculation that I don't need. So with this already being exposed to us by Unity, that's what I did. I just wrote my own copy of that function. And I just took the normal calculation out and left everything else the same. And you can see in this example how it works. Like on the left, you just have basically how the shader normally works, with the vertex colors superimposed on top of it. And on the right, you have the same thing with the same amount of light sources, just on top of that vertex shader and with the new lighting model. And you can see that usually this backside here should be way darker, but this doesn't care about that. And so we just get a nice, soft, uniform fall-off that ends up looking sort of 2D and painterly and translucent, which are all things that I wanted. OK, one more problem with this was that we couldn't have darkness. So I solved that in a similar way. So quick explanation, usually in Unity we have vertex and pixel lights, which do different things. But the important part for us in this case is that we can get them to calculate differently in the shader. So at first, I have pixel lights, which I'm using in the way that I just showed to make things brighter, as lights are supposed to do. And now I took vertex lights, and I made them make their surroundings darker. I just made them subtract light pretty much in the exact same way. So again, they do the same thing without the normal calculation and the soft fall-off, but we can now subtract light. So now if I need anything to be dark, I can slap a negative light in there, And the way it works, I can go and put positive lights on top of it again to brighten areas again. So now we can have caves and things like that. And we can have an area that's completely dark until the player uses a light spell, which is the first spell you get in the game, so that's kind of important. OK, so on top of this, I ended up building a couple more things. First of all, without any addition, we can now have tinted lights again and create moods like we would normally be able to do in lighting. I added fog back in, which is always nice to have. And I experimented with rim lights a bit, but those looked nice in some cases, but they made all the normals show up again, and apparently I hate normals, so that was discarded. And I did a terrain shader, which deserves special mention because it actually needs to pull a lot of weight in terms of design, and it's doing things a little bit differently. So the terrain doesn't have any vertex colors, so if we apply this shader that we have, it's basically completely flat. So the first thing I do is I introduce a simple height-based gradient to fix that a little bit. And I add fog back in, which is basically just a gradient in z-space. And last thing I do is I make it have cast shadows, which is a bit of a cheat because nothing else in the game has cast shadows. But this is sort of emulating one of the things that we wanted from the art. And it still isn't doing any of the normal calculations, so it's this flat shader with the cast shadows on top, which works nicely and is sort of similar to what we wanted. OK, I also did a water shader, where I just ripped out the Unity water, the Gerstner wave calculation, and fitted it on top of the Vertex shader. And I'm going to show you a video of that, because without movement, it's, yeah. So that's the Vertex water in action. And the Gerstner calculation is pretty much just what makes it go like this. OK, the last thing I'm going to show you is how we would end up using these in a scene. So what I really like about this approach, and what ends up saving me time, is that we start out with a neutral scene that pretty much just works. It's got all the stuff in it exactly the way that we designed. And technically, we could ignore 90% of it. And for the remaining 10%, like places that are important and that we want to draw attention to, we can make things differently. We can make them brighter, darker, we can increase the contrast, etc. And one thing regarding the game mechanics, one important part of the game is that the player is supposed to search for places of power where they can perform rituals. And you can unlock these areas with a spell. And if you were wrong and the place isn't a place of power, then bad things happen to you. And you're supposed to only identify these places visually, like a circle of mushrooms or a strange rock formation should really tip you off. So if this giant black monolith back there isn't suspicious at all, we can help things along a little bit by making this spot special in lighting. So this example is a bit on the overkill side for the sake of example, but we can now very clearly visually separate this place from the rest. And we can drop parts in darkness and increase contrast a little bit. And we can use these in an almost 2D kind of post effect, except that it still exists and works in 3D space. And we can just throw a very big adjustment on parts of our scene and we don't have to worry about which side it's hitting the object from. So in the end, instead of getting lost and trying to emulate realistic lighting scenarios, with this technique, we can focus on the theatrical aspects of lighting. We can generate mood, and we can direct attention, and we can ignore everything else because it's pretty much already there. Okay. Yeah. So that's basically it. Now you know how we can paint in 3 dimensions.
Do you have some time still for some questions? Are there any questions? Anybody here up front?
I don't know how really to explain it, but you showcased a little leaf, and it had like a little split. I just wanted to know more about that. Like, what did you do? Yeah, it was way in the beginning.
This one, yeah?
Yeah.
Yeah. So yeah, you mean how it's split in the left? Or how the color of it is split?
I don't. You said that it was smooth before, right?
Yeah.
And now you had this split. Like, how did you do that? How did it become such a hard transition? Is it edges?
Right. So in vertex coloring, we can adjust either faces or edges or vertices. And with this display mode on the left, I can split out the vertex in the middle on the right into its 4 different adjacent faces. So I can give those on top a brighter color. And at that point, it doesn't draw a transition between the 2 anymore. It just creates a sharp edge in between them.
All right.
Does that make sense?
I might ask you a little bit more about it later.
Yeah, sure. I think we're out of time, but I'm going to hang out in the speaker corner in the hall a little bit, and you guys are welcome to come by and say hi and ask questions, etc.